Introduction to Exponential and Logarithmic Functions. Okay. All right, in its simplest form, an exponential function looks like a base b raised to an exponent. And that base b can be any variety of numbers here. Okay, let's look at the example where that base b is a 2. So it says given f of x equals 2 raised to the x, which is an exponential function, we want to find f of negative 2. All right, now here all we have to do is plug in negative 2 for the x, so it'll be 2 raised to the negative 2 power. That is the same thing as 1 over 2 raised to the second power, which is the same thing as 1 over 4. Easy enough. You can also type these in your calculator. Let's do them by hand just to make sure we understand how they work. All right, how about f of 0? Well, this is 2 raised to the 0 power. Well, anything raised to the 0 power is 1. Awesome. All right, f of 3. That's 2 raised to the third power. That's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So our answer is 8. Now, if we're looking at exponential growth and we were to look at a graph, exponential growth has can be a pretty sharp upward curve that looks like that. Whereas exponential decay, obviously, it's kind of the opposite. It's kind of a sharp curve downward. Okay. Anytime we're looking at that graph, if we're looking at the very basic graph of an exponential function, remember that y equal b to the x, it's going to have a horizontal asymptote at y equals 0. And you can graph it and see that. Now, you can do some more advanced stuff where you have like a base raised to an exponent, and you have a constant a multiplied out front, and then you have a constant c that you're adding or subtracting from it, and that will adjust where that horizontal asymptote is at. But for the very basic exponential function y equals b to the x, you have a horizontal asymptote at y equals 0. Now, a number you see come up a lot when it comes to exponential functions is the number e. The number e is equal to like 2.71828, and the numbers just continue on. There's no really cycle to them. You just get a whole bunch of numbers. This is a number that comes up a lot with exponential. It's just a number. Treat it like a number. That number is located on your TI calculator. You can find it. If it asks you to use an e, you can use that e. A lot of the times it's used as the base. So it might be y equals e to the x in certain functions and be set up that way. That e just represents that number, that 2.71828, etc., 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 as it continues on. All right, now let's look on the other side at logarithmic functions. In its simplest form, a logarithmic function is of the form log base b of x, which you can kind of see here. Okay, the definition of a logarithmic function is y equals log base b of x, where b is your base. And the way it really sets up here is if you had, say, the log, we'll just do it straight out how you have it. Y equals the log base b of x. That is the same thing as b to the y equals x. Okay, that is the definition of y equals log base b. Okay, it's just b to the y equals x. Okay, and it's our way of evaluating for y in this scenario. Okay, what you'll learn here, and we'll get to it eventually, is that logarithms and exponential functions are inverses. So it's a way of essentially inverting it to actually find the value. Now we have a couple special cases here. If we have a log base 10 of a value x, a lot of the times we just write that as the log of x. If you see the log of x with no base term here, that base term is assumed to be 10. Now, if we have a case where we have log base e of x, most of the time we'll write that as the natural log of x. Okay, so log base e of x is the same thing as the natural log of x. And just to kind of have issues with students every year when they go to type this in on my math lab, this isn't a 1, this isn't a capital I, it is an LX. So sometimes I'll even write it in cursive as an LX, but this is an LN here. LNX, natural log of X. Don't write it as a 1 or an I or a vertical bar or anything like that. It is an LN X. Stands for natural log. Why they don't write the N before the L, I'm not really sure. They want it to look, because the log starts with the L. They want the natural log to start with an L. Logarithm, that's natural logarithm. All right, let's evaluate some of these given logarithms here, though. Now, if we were to look at this, I'm going to go ahead and write the X out here for it, and that's X is essentially what we're solving for, right? Here, the log base 2 of 16 equals X. We want to figure out what it equals. So we kind of need to think of it as 2 raised to what power would give us a 16. Okay. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I need 4 2's in order to get that 16. So here, X should be 4. So my answer would be 4. 2 to the 4th power will give me a 16. So log base 2 of 16 is 4. You can type that in your calculator, and it'll also evaluate it to 4. We're trying to do it by hand. Let's do this next one. All right. Log base 3 of 1. And I wrote equals X. So this means 3 to what power equals 1? Well, how about 0? Anything with the 0 power is 1. So here my answer is just 0. All right, log of 0.01. Ooh, now this one, a little different, right? It doesn't have the base written out, so we assume that that base is 10, right? So 10 to what power equals 0.01? Well, how many decimal places are we looking at right here? We're looking at 2 decimal places, correct? And if we were to raise 10 to 2 decimal places, what will we get? We should get the 0.01. So X here should equal negative 2. Like I said, you can always check it on your calculator. All right, now when we're talking about logarithms here, logarithms can grow and decay as well. They grow and decay a little different. Their growth kind of starts out and looks like this, kind of plateaus out. Their decay kind of starts as a plateau and then kind of drops off. All right. For these, you have a vertical asymptote. You typically, for a general logarithmic function, you'll have a vertical asymptote at x equals 0. Okay. At x equals 0. All right. Now, some of the things that we like to do is be able to convert back and forth from exponential to logarithmic or logarithmic to exponential. Okay. So here we've got this first one here. We want to convert this to logarithmic form. We have 2 raised to the x power equals 3. Okay. The way I would convert this to logarithmic form is I would write this as log base 2 of 3 equals x. Easy enough. All right, now this one. I've got w to the x power equals y plus z. All right, this is going to be log base w of y plus z equals x. Okay, and I put that y plus z in parentheses on purpose to make sure that you know that both are included in that logarithm. All right, here I have 3 squared equals 9. I'd write this as the log base 3 of 9 equals 2. Logarithmic form. All right, how about these? Well, I have the log of x equals 3. Now, it doesn't give you a base here, so the base is assumed to be 10. So if I were to convert this from logarithmic form to, really what I'm trying to do is logarithmic to exponential. So we're really trying to convert this to exponential form. Okay, so this would be 10 to the 3rd power equals x. Something I could actually solve, right? All right, now this is the natural log of y equals 5. what base does natural log have? Natural log has base e. So if I convert this to an exponential, it'll be e to the 5th power equals y. And remember, e is just a number. So it'll essentially solve for y there. Now this one, converting this one to an exponential. Log base 3 of p equals q plus r. Well, this will be 3 to the q plus r power equals p. Easy enough. And that, like I said, hopefully was a fairly straightforward lecture. That is our introduction to exponential and logarithmic functions. If you have any questions, let me know. And I will see y'all next lecture.